Hello, everyone, and welcome to our nonprofit IT renovation waterfall charter portion of the proposal, done by Group 4, which includes Mason Roller, Liz Flores Rodriguez, Seth Olson, Jeremy Gardner, and myself, Edward Wilson. We have a nonprofit that's working with some old and outdated equipment, and we need to replace that. Every year we get 60 students that come in. They're confronted with this Windows XP Vista stuff and these incredibly slow computers, and they just get really demoralized. We even had one student who actually calculated that they were spending an hour per day just waiting on screens and tools to load. Permanent staff, 90 people, also frustrated, even though their computers are typically only 3 to 5 years old. They were typically cheaper computers that were purchased. They have slow spinning hard drives, and they don't work for what we need them to work for, and that gets to be expensive. One of the calculations that we do in terms of productivity loss in IT world is to look at the number of minutes per day we can gain from an IT renovation. If we have workers who are losing just 1 minute per hour, 8 minutes per day, 5 days per week, that's 40 hours a week, 5 days, 50 weeks a year, then we're looking at over $1,000 per year per staff member. And we have something like an equivalent of 120 full-time staff people by the time the students are averaged out. And what that means is we're losing well over $100,000 per year just in productivity loss, almost no matter how you look at it. Originally, when we looked at this project, we had two options. The one that we'd been going with was to buy new Dell refurbished PCs with a 5-year warranty. The total hard cost for each delivered PC was about $750. We needed about a half hour of IT time at $50 per hour, which brought our total cost per delivered PC to $775. Because we're only looking at a budget of $25,000 per year, that meant that using the new Dell refurbished PCs, we could only replace about 30 per year. So over the course of the next 3 years, we'd have gotten rid of most of the worst computers. But during that 3 years, people still would have been having problems. We still would have had the productivity losses and so on. What we found as we started to research that project was that we could approach one of the large companies in town, a public utility named Ameren, and they had some computers that they were life cycling out. Now, these computers were 4 years old, but the initial cost was free, which is very attractive. They came without hard drives because the public utility had to crush the hard drive. On the other hand, that gave us an opportunity to upgrade these to a solid state drive. They had 2 to 4 gigabytes of RAM. Some of them had 8, average of 4. We can put in another 4 gig stick of RAM. We can get them to 8 gigabytes. It takes about 2 IT hours to deliver that computer because we have to go get the computers, remove the hard drives, upgrade the RAM, insert a new hard drive, deliver to the end user. There's a little bit more time in there. And these are 40% depreciated relative to the new computers. On the other hand, we anticipate limited 5-year maintenance costs because we get a 3-year warranty on the solid-state drive. We've got a lifetime warranty on the memory that we want to put in. We're going to get 10 to 15% additional computers in just for spare parts, motherboards, power supplies, etc. And something that we didn't mention here, but we want to take into account that somebody talked about before, is that we're also going to have all the older PCs that we collect. So some of those 3-year-old PCs, as we collect those, we'll actually be upgrading them as well along the way, and that'll give us another 50 PCs in stock. So the fact that we're able to get 150 of these donated PCs, plus the PCs that we're going to pull from inventory, means that we should be able to get everybody taken care of, and we should have spare parts to get us through the next few years on this cycle. The hard cost per delivered PC we calculated at $100 each. We'll delve into that later. And the total cost per delivered PC of $200 comes because we add those 2 IT hours at $50 per hour. And by doing this, we're going to be able to replace all those PCs during that first program year for about $15,000 in materials. That's our upfront look, and a total cost of about $30,000. Now remember, we had $25,000 per year budget, but that's just a hard cost budget. We also get to use some IT hours, and so we've negotiated to cap that at around $5,000 so we can fit in that $30,000 budget. And the big gain that we have by doing this is that the lost productivity for staff during our next 2 or 3 years is minimal. Whereas if we went with the new PCs, we would still have all those people who would be frustrated year over year in order to implement that project. Because we'd only be able to replace about a third of the ones that we need to per year maximum. We were able to come up with this methodology for putting these into play. that we thought was pretty good. So having done the analysis and having selected the old refurbished PCs, we've got to get them ready to put them out there. And a typical PXE boot environment or thumb drive image that we might use is probably not a good solution for these computers. However, because they are all the same computer, we can build a source or reference image on a single solid-state drive, and then we can copy that using a disk cloner that takes one cloner, you put in 5 blank, or one source image, put in 5 blank ones, and it clones it onto all those 5 blanks. It takes about 20 minutes to do that for the 5 disks, so we can get through that pretty fast. We also need to update the BIOS on each of these, and we bought a 4-unit KVM over IP, which basically lets us use one screen to work on 4 computers at the same time, and we're able to then update all the BIOSes on those computers, and we can do about 4 of them in about 30 minutes or so. For resources and costs, obviously we're going to need the hard drive cloner, and the client decided they wanted to purchase that for future use, so that was about $350. We've got 12 hours per week of a project manager's time. That's a little bit of a fuzzy number. It can scale up if it needs to. And we have about 40 hours per week of IT labor. We're also looking around 60 hours of volunteer labor. We've got a couple of volunteer groups that will help us extract these from the public utility and deliver them back. And when it comes time to assemble, we're going to have a pizza party, and we're going to invite everybody in to help build their own computer. If we get 20 or 30 people, they spend half an afternoon. We're going to be flying. Microsoft is providing these Windows 7 Pro to Windows 10 Pro upgrades at no cost. And I say Microsoft, I'm probably giving them a little bit much credit. These were originally sold with the idea of an upgrade, and so we can actually unlock Windows 10 on the existing Windows 7 Pro COA. Now, caution there. As we've looked at the hours that we need, and then we're going to talk about that a little bit more in the upcoming slides, if we look at those hours that we're going to need, we calculate that between 256 and 300. 300 was our first look, and as we got really down to it after making that proposal, we thought we had 256 work hours that were going to be in it. You'll notice under my resources, I've only laid out 268 hours, so that's going to be tough on the time, and we're going to have to be careful that we don't run over. We may need more volunteers, we may need more IT time, whatever it is, so we're going to have to be a little bit soft on that delivery date. The hard cost per PC for doing this, we've got specific costs now. Very happy to announce that Micro Center has actually decreased the prices on our 240 gigabyte solid state drives for us to $50, $25 for the RAM, $6 for the adapter that we need. We are now down to only $81 per PC. So our initial look was $100 in our proposal, but now as we're at the charter stage, we're looking at $81. So we've had a drastic reduction there. Still looking at around 2 IT hours per PC, and a cost that we hadn't considered up front, but that we're adding now, is an DisplayPort to HDMI cable, which will connect a second monitor. The computers that we're putting in place have a VGA port and a DisplayPort. The monitors that we're using don't have a DisplayPort. They've only got an HDMI in, so we need those DisplayPort to HDMI cables. Not everybody has 2 monitors. We're going to allow for 50 of those at $990 a piece. Thanks to the significant cost reductions that we've had in our overall cost for the PCs, we're coming out well ahead. Feasibility. It's always important to have tested this, and we've actually put out a couple of contributed machines. We did the whole process, and we put them out to the end users. They were very happy with the results. These work great. In fact, testing those relative to the newer Dell machine that we were purchasing with solid-state drives shows no real performance lag on the older machines after the upgrade. However, prior to our deployment, we are going to have another 10 of these that we're going to spin up, and we're going to give them to key people throughout the company in different departments and doing different things to make sure everything works. And we're going to let those season in place for a week. That will become their actual work computer. And that way, if we need any tweaks or adjustments to the image or to the process or whatever, we'll have seen that in advance before we go ahead and try and deploy all 150. That'll give us a pretty high degree of confidence in our finished product. The final delivery of these 150 domain joined PCs includes that the PCs will have at least 8 gigabytes of RAM, a quad-core i5 processor, and a 240 gigabyte solid-state drive. They will have Windows 10 Pro with a 64-bit OS and all required company software installed. See that part we were talking about before with the extended testing? That's one of the things we're going to have to make sure of. PCs are going to work fluidly with all the attached peripherals. The drivers, etc., are all going to be installed. Keyboards, mice, printers locally, and that kind of thing. And they're going to be domain joined at the time they are delivered so that they can pick up all the group policies and other things they get from an Active Directory environment. All required licenses have to be valid, and we're going to be documenting those for the client as well. Project completion should be within 4 weeks of approval date, plus or minus 1 week. We are getting a little bit of fuzz time with that. Project to be within 10% of the approved budget of $25,000 for fiscal year 2018. That's the number we can't move a lot, so we really need to hit it. Dropping the cost to $81 per PC has given us a lot of elbow room. We're looking at picking up then somewhere in the neighborhood of $2,500 of spare fuzz money, whether we run over in labor or whatever happens. The IT labor for this project is calculated separately. So we get $5,000 of IT over the $25,000 cost. But as you can see in 3A1, if we are able to decrease our total materials spending, that gives us more IT labor. For instance, if we only spend $20,000 materials and $10,000 in IT labor, that's $30,000 total, which is $5,000 over our original budget, and that's acceptable. Exclusions. We're not adding any monitor, mice, keyboards, or other peripherals to this project. The stuff that's in place is working, and that's what we're going to use. We don't have to bring anything else to the table other than the ability to connect to those monitors and so on. The client is being provided with all the end warranty information. So there's a lifetime warranty, for instance, on the RAM modules and 3-year warranty on the solid-state drive. We give them the warranty information. They're responsible for fulfilling that. This is a delivery project only. We don't have any penalty metrics for project completion outside the indicated deadline of 4 weeks. It might take 6 weeks, 8 weeks. No penalties there. Primary risks are approval and shipping delays, and of course making sure that we're able to get all of those donated computers. However, we've been over to the facility. We've seen the computers. We've got their email commitment to give them over to us. So as long as that happens, we'll be moving forward just fine. The risk is if it doesn't happen, we're back on the original plan of trying to replace with the new refurbished machines. Project manager fees will reduce by 10% if it runs over cost, though. That's kind of our hard metric that we're looking at. And after deployment, each department head will sign off on satisfactory deployment metrics and the user acceptance within 1 calendar week. Anything discovered after that becomes part of a new scope. For mitigating our risks, we've got a failure to obtain materials. However, we've preliminarily sourced all materials from at least 2 sources, and nothing is happening other than that cost going down. So we still feel pretty good about that at this stage. Faulty materials. We do expect to have some faulty PCs coming in. Again, we're looking at 10 to 15% overages in terms of donated PCs. So instead of being actually donated 150 PCs, we're going to get 175 PCs. And that gives us a little bit of a safety buffer there, as well as some spare parts for power supplies, motherboards, processors, whatever we need that can come from those. Going over budget on money or time, additional money may not be readily available. Time will probably be okay with, but money's not coming. So we have to be very complete up front, make sure we've done our in-place field testing in advance with a high degree of confidence so that when we get this project, we're going to be able to execute it within the money that we've talked about. Somebody mentioned not getting our volunteers to show up. The project is not dependent on volunteers. So that's a bonus that helps us get done on time and under budget, but it's not going to be a requirement for completing the project. And of course, there was a concern about getting the pizza at the right place. Turns out Papa John's is going to donate the pizzas, so we're pretty happy about that. The next couple of slides are just for you to look at here. These are our work breakdown structures with the different paths that we've got in place. The project hours, which includes wait times, work hours, which includes the man hours. That's where we get the 256 as we broke it down. This is an outline structure, and for those of you interested in looking at the critical path, here you can take a look at what we have going on. It's the hard drives, cloning them and getting them installed is what we're most focused on. With that, we're ready to execute. All we need is a green light to go on to the next step and start implementing. Thank you so much for checking it out. We here at Group 4 appreciate your support.